Hello everyone, my name is Sahar Badihi from the University of British Columbia, Canada, and I'm here today to present our benchmark of equivalent and non-equivalent programs. The goal of our benchmark is to help evaluate and improve equivalence checking techniques. In short, equivalence checking formally proves whether two versions of a program produce the same output given the same input. Equivalence checking has different applications, such as regression verification, refactoring assurance, and compiler optimization. Here are a few examples of benchmarks used in recent popular equivalence checking techniques. You can see that they're relatively small, up to 14 lines of code on average, and contain no difficult programming constructs such as floating point and nonlinear arithmetic. Our earlier work, RDIF, extended these benchmarks in both size and complexity. Yet, these benchmarks still did not include a string array and object manipulations and were written in Java only. We now extend this work, contributing a large and comprehensive benchmark, which we call EQBENCH. EQBENCH includes 272 complex programs with nonlinear arithmetic, string, array, and object manipulations, challenging for most equivalence checking techniques. We capture all programs in both C and Java. To create EQBENCH, we translated existing benchmarks from C to Java and from Java to C, and also contributed 102 newly generated cases. For these, we followed the same methodology as RDIF, starting from computation-intensive programs collected in earlier work. Since these programs were designed to validate symbolic execution techniques rather than equivalence checking, we had to create equivalent and non-equivalent cases for each program. To generate non-equivalent cases, we modified arithmetic expressions and conditionals. To generate equivalent cases, we used existing code refactoring techniques such as variable inlining, and when not possible, we inserted dead code or renamed variables. The benchmark repository that we provide stores each benchmark in a separate folder, where it further includes two subfolders, egg and neck. Each egg and neck cases has two versions, one in Java and one in C. For each version, we also provide two files that contain the metadata describing the benchmark. Besides the general information such as name and the size of the code, the metadata include the type of changes between the original and the changed program, and a counterexample for neck cases, which is values for the input parameters, making the changed program non-equivalent to the original. Our benchmarks are publicly available in an archive repository and also in GitHub. Thank you, and feel free to contact us with any questions.